Welcome to our symposium, The Grammar of Tool Use, where we were talking about converging processes in grammar and compositional tool manufacture. I introduce myself briefly. I am Antonella Tramacere and I work at the Max Planck for the science of history. As I sit down. Sorry, but I was running to find the speakers. And I work on an evolutivo approach to the evolution of imitation and self-awareness, and to a biological cultural account of the mirror neuron system that I consider the basis of this cognitive function. So today, with Natalie, that will introduce herself, we will talk about these topics. So please.
Okay. Welcome everybody, and I'm Natalie Uomini, and to introduce myself, I studied linguistics and cognitive science and archaeology, and now I work on birds, and I'm working on the grammar of tool manufacture in New Caledonian crows. But I'm interested in particular in the evolution of language and tool skills and the cognitive underpinnings of those things. And so with Antonella, we have a very nice synergy because of our complementary areas of expertise. And so we are very excited about this session, which brings together different disciplines that do not normally communicate with each other. Some of the theories about what makes tools and language special have been proposed. For example, that there's an evolutionary trajectory in which innovations are appearing throughout time and they get accumulated. So this is the idea of cumulative culture. There's also a proposal that tools and tool making and tool use and language share different types of very fine motor control, particularly in the hand. So when you're making and using tools, you have a fine control of the hand articulators. And in speech, we also have very fine control of larynx and breathing. And finally, there's an idea that perhaps tools and language involve a transformation and creation of reality. So when you take a piece of rock and you strike it to make a tool, then you're really transforming this thing. And similarly with language, you know, when you speak or communicate an utterance, you're transforming these stream of sounds into something that has meaning. In particular, so the evolution of technology, what we know from the human lineage is that there are several main milestones, the pun is intended, in evolution of technology. So one of the first ones would be in this pre-Oldowan or Lomequian stage, where this is seen as a momentous cognitive threshold that is different from all the things that were happening before. I think one of the next milestones is when tools were really incorporated into the daily life, the survival of hominins. So they really began to rely on meat, which also fueled then the expansion of their brain size. And tools were really in the daily life. They were necessary for survival, and also then the young children had to learn these skills. And I think probably the sort of third milestone is in the late Acheulean, when you start to see these very finely worked tools that are extremely elaborate, that's much beyond the functional necessity of butchering carcasses, and they're really putting a lot of time and thought and effort into shaping these tools, and then you see very widespread technology, which is very similar across the world. So this is an example of how the cumulative culture can be occurring in technology, And similarly, in the language area, we also know that languages evolve and change and diversify. And for example, the great diaspora of languages that we see around the world today are emerging from these really, diversification and accumulation of changes. In terms of the fine motor control, we see that, will it click? For making stone tools, is it playing? No. Okay. I think there's a problem. It's a problem with the video.
And then what you're going to do is put a pad in your hand, if you like.
So stone tool making really involves the fine control of bimanual coordination, hand laterality, which we'll hear more about in the talk by Marina. There's like the opposable thumb that's particular to humans. And so this visual spatial coordination is very important. In vocal control, we also know that we need really fine control of larynx. We need control of the breathing also. And there's this great plasticity in vocalization. So humans are vocal learners, many other species as well. And these things are being controlled by the brain. So the topic of this symposium is the question, one of the big questions going on right now is about whether tools and language are the product of convergent or parallel evolution. So this is the question of whether they arose from a same common origin or if they evolved in parallel separately.
So, yeah. We're happy that it's so fun. But this picture is just to highlight the problem. Are tool use and language coming from the same process and so the same also time in our evolutionary past, or at a certain point during the Paleolithic or even later maybe the cognitive capacities of hominids have been co-opted for linguistic capacities. And some of the people that emphasize that convergent processes among these two cognitive capacities, like, for example, one of the most famous is certainly Darwin, that was saying that both processes rely on complex planning and coordinated action. And from the beginning, these two, the commonality between these two processes were involving the sequential and compositional control, common neural mechanism much later, and laterality. Regarding the sequences, we know that not only in language but also in tool use there is a compositional structure, an order of action that has to be performed in a certain way in order to build a functional tool. Here you can see an example of a basic flaking where it's necessary to do certain action first of others, then others, for example, identify geometry, rotate, turn the core, tilt the core in order to make a functional tool. And in relation to common neural mechanism, that is something that Thomas will talk about later, there are different studies that show that both the perception and the production in the linguistic and in the technological domain rely on a core mechanism or core region or pattern in the brain that involved a region in the frontoparietal and in the temporal cortex. Of course, there are also regions that are specific to one or the other processes, but there is a core action perception mechanism that is common to both cognitive traits. And this was also the basis of the mirror neurons hypothesis that gave speeded up the study of the commonality between language and technologies, because the discovery of neural mechanism or neurons in the premotor cortex of the macaque activating for execution and perception of action led different scholars to hypothesize that this action perception matching mechanism was then co-opted for imitation, pantomime, and then recruited and transformed in the vocal domain for a flexible mechanism for vocal control. And there are different studies that highlight this, both in the perceptual and in the executive domain, as you can see also in this picture. But there are also people that highlight and emphasize that, okay, there are common mechanisms among language and technologies, but it is not different from what is common in any type of action or motor system, like also locomotion. There are instead much more parallel feature or specific feature that distinguish language from tool use and tool manufacture, that regard, for example, the fact that language is a free syntactical structure. You can have, you can compose language with different rules that we see nowadays in different language. Or it's very famous also the case of arbitrariness in the semantic. There are words that are not obviously connected to their referent or to the meaning, and this process is the product of convention, a conventional history, but also the fact that there is an high fidelity imitation that is much more prominent in the linguistic domain, where you have to reproduce and copy with much more fidelity and preciseness the words of others to create a convention and a common basis for communication, while this is not so obvious in the technological domain. And of course, as we were saying before, we have a specific neural implementation for linguistic capacities that maybe are peculiar to understand how language evolved. So this was a general introduction for the topic. Now we will leave the stage for our speakers. The first is Thomas Gosha, I hope is right, neuroscientist and genetist, and then Marina Mosquera Martinez, archaeologist and primatologist, will take the stage. So please.